In the projectile weaving machine, the insertion system is simulated here, the projectile flies through a guide until it reaches the goal, bringing the weft thread to the other side of the shed. The end of the weft thread is held by a clamping device in the projectile. The projectile does not carry along a supply of thread. It pulls the precise length of a weft thread through the open shed. But how is the projectile shot through the guide? Where does it get the energy? This is handled by an accelerator or picking mechanism built around a torsion rod made of a special metal alloy. When turned about its axis, hardly visible to the human eye, it stores enough energy to shoot the projectile across to the other side. Let's take another look. The torsion rod is turned and loaded with energy. The picking lever connected to the rod actuates the shot. The next thread is transferred. The picking mechanism goes to work and another projectile is on its way. Before the projectile clamp releases the thread, it is taken over by the selvage gripper. Thus, the thread is under control at all times. When the projectile has reached the receiving unit, the weft thread is detached from the package prior to each new shot. As soon as a projectile has returned to the picking position, it receives the new weft thread and is hurled on its way again by the accelerator mechanism. After its rapid flight, the projectile slowly travels back to the picking position. The larger the weaving width, the greater the number of projectiles in circulation. In modern projectile weaving machines, this process can be repeated more than 400 times a minute, inserting more than 1,000 meters of weft yarn. This machine is equipped with a weft mixer. The weft thread is alternately withdrawn from two different packages. It passes through the weft brake, then through the weft tensioner, and finally, the projectile feeder passes it on to the clamping device of the projectile, which inserts it into the shed.